Good morning, one and all. My name is V. Abhijit Kumar. I'm studying in BTech first year, CSC AIML, that is Computer Science and Engineering with a specification of Artificial Intelligence and Machine Learning, second semester, Institute of Aeronautical Engineering. In this video of the AAT assignment of the complex engineering problem in the subject of EPS, that is Essentials of Problem Solving, the topic assigned to me is palindrome linked list. So I'm going to explain about the topic of palindrome linked list. Let's go through the contents which I am going to go through one by one in this presentation of mine. In the first place, I'm going to explain the problem statement given to me, and after that I'm going to explain about the constraints, expected input and output which are expected from me, and after that I'm going to explain about the sample inputs and outputs which are given to me, and I'm going to explain about the approach to solve the given problem, and after that I have a Python code with mine. In the first place, I'm going to explain about the helper functions, and after that I'm going to explain about the main function, and after that I'm going to explain about the driver code, which are all the part of that Python code which I have, and after that I'm going to explain about the execution of that Python code, and after that in the final place I'm going to conclude the topic. Now let's go through the problem statement given. The task which is given to me is that if given a singly linked list, I have to check whether it is a palindrome or not. A palindrome, as we all know, is by definition any phrase which reads the same forward and backward both at a time. And after the end of the solution of this problem, the output which is expected from me is that the program should return yes if the phrase or the list is palindrome, and it should return no if it is not a palindrome. So this is the scenario of the problem statement of the topic of palindrome linked list, the complex engineering problem given to me. Now let's go through the constraints, the expected input and output which are given to me. The first constraint is that the required n must be greater than or equal to 1 or lesser than or equal to 10 to the power of 6, as we all know in this problem statement. The elements in that list must be either integers or characters. The time complexity is O of n, the space complexity is O of 1. The input, as discussed before, is a singly linked list, and the output, as discussed before, is either yes or no. So this is the explanation of the constraints, input and output expected in this problem given to me. Now let's go through the approach I gave to solve this problem. The first step is that I'll find the middle of the linked list. In the second place, I'll reverse the second half, and in third place I'll compare the both of the halves. In the fourth place, if or if not, I'll restore the list, and in the final place, as discussed before, the output will be either yes or no. So this is the explanation of the approach I'll give to solve this given problem. Now let me tell about the sample inputs and outputs which are expected in this problem. The sample input, if it is RACECAR, race car, it is a palindrome, the output must be yes. And the sample input, if the input is 1221, it must be yes. And if it is HELLO, hello, it must be no, as we all see. And if the input is a single element, it is always a palindrome, so it must come yes. And if the input is A, B, it must come no, as we all can see. So these are the sample inputs and outputs which are expected from me in this problem. Now let's go through the Python code which I had made in Jupyter Notebook. I divided this Python code into three parts as discussed before. The first one is the part of helper functions, the current slide, and the next two parts I'll discuss them later after this slide. Coming to this slide, in the first cell I defined two important functions for a linked list. The first function, reverse list, reverses the linked list by changing the direction of the next pointers one by one. The second function, find middle, finds the middle node of the linked list using two pointers, one slow and one fast. Hence, these two functions will help us later to find if that linked list given is a palindrome or not. Hence, this is the first part of the code I wanted to share with you. Now let's come to the second part of this code, the main function, which helps us to find whether the linked list reads the same forward and backward at a time or not. In this second cell, I defined the main function is palindrome. As you can see in the code, this function checks whether the linked list reads the same forward and backward or not. As I have told, it finds the middle node. It reverses the second half of the list and it compares the first half and the reversed second half node by node. If all values match, it returns yes, otherwise it returns no. Hence, this is the main function which I had made as the second part. Now let's go to the third part. In this third part, the driver code of this entire program, I wrote the driver code to test the previous functions. First, I created a node class, as you can see in the code, and I created a create linked list function with underscores in between, as you can see in the code, to build a linked list from a normal Python list. Then, for each example list, I had created a linked list and called the isPalindrome function. Hence, the final output prints yes or no by depending on whether the given list is a palindrome or not. Now, as you can see, in the execution, I had made a tabular form of the entered inputs and the received outputs. In the first place, I had entered the race car, as you saw in the previous code, the driver code. It came yes as the output, and after that 1221, it came yes, and after that HELLO, it came no, as we can see that it is not a palindrome. And after that, a single character X, it is always a palindrome. Any single character is always a palindrome, as we all know. So it gave the output yes, and after that AB, as we can clearly see, it is not at all a palindrome. Hence, it has shown the output as no. Hence, this is the final execution of the code which I wanted to show you. By concluding this topic, we successfully checked whether a singly linked list is a palindrome or not by using the certain efficient linked list techniques. We, in the code which we had executed, found the middle part of the list, reversed the second half, and compared both of the halves, the first half and the second half, without using any kind of extra space. This method ensures O(n) time complexity and the O(1) space complexity, making it both time efficient and memory efficient at a time. So, by carefully manipulating the linked list, we finally achieved the correct needed wanted results for all of the test cases. Hence, this is the final conclusion of this topic. And finally, I would like to thank the respected professor who had given me this wonderful opportunity to speak upon this wonderful topic in the context of this complex engineering problem AAT. Thank you.